Alright, so problem 14. So a pizza delivery service claims that it will deliver the pizza within 30 minutes. But one customer believes that that's not true and the delivery time is longer than 30 minutes. So he takes a sample of 9 customers and finds a mean of 33.2 minutes and sample standard deviation is 3.4. So you have to test the customer's claim at level of significance 0.01. So this is a one population problem. It's a means problem. The sample standard deviation is known, so sigma is unknown, and it's chapter 8 problem. Now we go to hypotheses. It's like H0 and HA. Because it's one population means problem, so we should talk about mu. Now here the customer claims that mu is bigger than 30. Of course, versus H0 should be mu equals 30. Since sigma is unknown, the test statistic shall be T equals x bar minus mu naught divided by s by square root of n, which if you plug in these values is 2.8235. Next comes rejection region. So it's a t test. So first I shall draw the t curve. Which t curve is it? It is t with degrees of freedom n minus 1. N is 9, so n minus 1 is 8. And it's a right-tailed test. So for a right-tailed test, I'll draw a right tail. There's TC and area like right of TC. And how fat should be this tail? It should be 0.01 fat. One tail 0.01 and degrees of freedom 8, which if you look it up, so one tail is 0.01, that's here, and degrees of freedom is 8, so that's 2.896. So TC is 2.896. So what's the actual reaction region? If T is bigger than TC, you reject H0. Does that happen for us? For us, it's 2.8235, which is actually smaller than TC. Hence, we fail to reject H0. So in conclusion, if we fail to reject H0, that means we have not proved that they take more time than they claim. So we have failed to prove mu bigger than 30. We stick with mu equals 30. So conclusion, company delivers in time. So according to a survey conducted by Association for Dressings and Sauces, okay, I didn't know that there was such a thing. 80% of American adults eat salad at least once a week. A nutritionist suspects that the percentage is higher than 85%. She conducts a survey of 200 American adults and finds that 171 of them eat salad at least once a week. Test whether the proportion is higher than 85%. At a level of significance 0.10. Alright. So it's one population means proportions problem and chapter 8. So it's one population. In the hypothesis, you should be talking about P. Now, this nutritionist claims that P is bigger than 0.85. So your H0 is P equals 0.85. Your HA shall be P bigger than 0.85. Next, test statistic is like this, where P hat is R by N, which is 0.855, and P naught is 0.85. If you plug that in, you get 1.94. Now rejection region. For rejection region, it's a z-test. So I shall first draw a z-curve. Then I'll look at HA. It tells me it's a right tail test. So for a right tail test, I will draw a right tail. How fat should be the right tail? It should be 0.1 fat. So it's 0.1. That means area left of ZC is 0.9. So if you search for 0.9 in the Z table, you search for 0.9 in the Z table, and 0.9 lies between this number and this number. So between 1.28 and 1.29, hence it's 1.285. ZC is 1.285. Okay. Now you reject if Z bigger than ZC. Does that happen? Yes. 1.94, our Z, is bigger than 1.285 ZC. So you reject H0. You reject H0 means you go along with this HA, which tells you that it's true. The percentage of people who eat salad once a week, at least once a week, is more than 85%. Two friends, Jody and Karen, work different shifts for the same ambulance service, and they are thinking that if different shifts average a different number of calls. So Karen takes a random sample of 29 shifts and finds a mean of 5.2 calls per shift with a sample standard deviation of 1.3. Jody takes a random sample of 28 shifts and her mean was 4.8 calls per minute with a sample standard deviation of 1.2 calls. Alright. So test whether there's difference between the two shifts in number of calls. And your level of significance is 0.05. So it's a two populations problem. It's a means problem. And sigma 1, sigma 2 are not known. Only sample standard deviation is known. And it's chapter 8 problem. So for the hypotheses, since it's two population means problem, we should be talking about mu1 minus mu2. Now they are only thinking about whether there's a difference. They're not saying which one is higher, which one is lower. So we should be like mu1 minus mu2 not equal to 0. That means there is a difference. And H0 is mu1 minus mu2 equal to 0, which means there is no difference. Next, test statistic. So because sigma 1, sigma 2 are not known and it's a means problem, it should be T equals x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. And you plug all these values here and you get 1.2077. Next, rejection region. So since it's a T test, first let me draw a T curve. Now, which T curve is it? It's T with degrees of freedom, like minimum of n1 minus 1 and n2 minus 1. n1 minus 1 is 28, n2 minus 1 will be 27, so degrees of freedom is 27. Next, is it a one right tail or a left tail or two tail? It's a two tails test, so I'm drawing two tails. Area right of TC and area left of minus TC. How fat should be the two tails? It should be 0.05 fat. So we look for two tails equal 0.05 and degrees of freedom 27. Two tails equal 0.05 and degrees of freedom 27. So it's 2.052. TC is 2.052. So when do we reject? If T bigger than TC or T less than minus TC, then you reject H0. Does that happen for us? No. For us, T is 1.2077, which lies between TC and minus TC. So we fail to reject H naught. So if we fail to reject H naught, that means we kind of accept H naught, although we don't say that, which means mu1 minus mu2 equals 0. So we are saying there is no significant difference between the two shifts. That's our conclusion. Problem 17. Alright, so this is an interesting problem. So a company hired some people and charges were missed. Charges were drawn towards them that they are discriminating people based on age. That means they are hiring young people. That usually means they are hiring more and more young people, and you cannot do that. That's the claim. So how is the data being presented? So we are looking at all the unsuccessful people, who did not get the job, who applied for the job but did not get the job. So there are 50 people like that. What's their mean age? It's 47. And what's sigma? Sigma is 7.2. All right. And successful people, there are 40 of them. What's their mean age? 43.9. And what's sigma? It's 5.9. So I should be really writing X bar here. X bar is 47 and X bar is 43.9. That means N1 is 50, X1 bar is 47, sigma 1 is 7.2 as given. N2 is 40, X2 bar is 43.9, and sigma 2 is 5.9. Alright, so that's our data. Now it's a two populations problem, obviously. It's a means problem, and sigma 1, sigma 2 unknown. It's given here. And it's a chapter 8 problem. So hypothesis, H naught. H naught should be about mu1 minus mu2 because it's a two populations means problem. So mu1 means unsuccessful, mu2 means successful. So if the allegations are true, then unsuccessful people should have a higher, mu1, the age of unsuccessful people, the mean age of unsuccessful people should be bigger than mu2. So mu1 minus mu2 should be positive. And H naught is mu1 minus mu2 is 0. That means there is no difference. So since sigma 1, sigma 2 is known, we are going with a z test, like a z test. So z equals x1 bar minus x2 bar divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. That's given in the formula sheet. And if you plug those numbers that you see here, this will be 2.24. Next comes the rejection region. So it's a z test. So we draw a z curve, and it's a right-tailed test. So we draw the right tail. How fat should be the right tail? It should be 0.05 fat. Alright, so ZC, area to the right of ZC is 0.05. Hence area to the left of ZC is 0.95. If you search for 0.95 in the Z table, you shall get 0.95 lies between this number and this number. Hence 0.95 corresponds to 1.64 and 1.65. So your ZC lies between 1.64 and 1.65. So your ZC equals 1.645. So if Z bigger than ZC, that means the right tail, reject H naught. Does that happen for us? Yes. 2.24 is bigger than 1.645. Hence you reject H naught. What does that mean? You reject H naught means you have proved this, That means, yes, the average age of unsuccessful people is higher than the average age of successful people. That means that's what I wrote. The unsuccessful group has a higher mean age. Uh, the last problem is from chapter 9. Uh, so the x and y points are given. There are 5 points given. And for you, I have given out these: sigma x squared, sigma y squared, and sigma xy. Your job is to find the correlation coefficient and the regression line. So correlation coefficient means R, which is n times, basically this is this formula. Once again, this formula is not in it is in the book, but it is not in the formula sheet. So please make corrections about that. Like, write down this on your formula sheet. And if you plug these numbers, like n is 5, I've not given that, but that's obvious. 1, 2, 3, 4, 5. And if you plug the rest of the numbers here, you shall get 0.9873. And then comes that's correlation coefficient is done. Next comes the regression line. The regression line is y hat equals a plus bx. But a and b has their own formula. So b is, and this formula given here, I'm not speaking it out, which once again, if you plug the numbers, you shall get 4.5839. And a is y bar minus b times x bar. So by the way, we have b, but we need y bar and we need x bar. So what's y bar? It's sigma y divided by n. That makes sense. Y bar is the average of y's. So you sum up all the y's and divide by the total number. So if you plug in the sigma y and n equals 5, this comes out to be this. Similarly, x bar is sigma x divided by n. Once again, you plug in this value of sigma x and you plug in n equals 5, you shall get this value. So you have y bar, you have b, you have x bar. You get a is minus 8.279. So what's your regression line? It's a plus bx. So y hat equals minus 8.279 plus 4.5839x. Yeah, that's it.